Next, we're going to delve into the core principles of prompting when working with large language models. Understanding how to craft effective prompts is crucial for guiding the model to produce the responses we desire. The four key components of a prompt. So, what makes a good prompt? There are four key components we should consider. 1. Instruction. 2. Context. 3. Input data. 4. Output indicator. First up is the instruction. This is where you clearly define the task or action you want the model to perform. It sets the stage and directs the model's response. Example instruction: classify the text into neutral, negative, or positive. Next is context. Providing additional information or background helps the model understand the task more accurately. This guides it toward the desired outcome by setting the scene. Example context: consider the nuances of customer feedback when analyzing sentiment. The input data is the specific question or content you need the model to respond to. It supplies the necessary information for the model to act or provide insights. Example input data: text, I think the food was okay. Finally, we have the output indicator. This specifies the desired type or format of the output, guiding the model on how to present the information according to your expectations. Example output indicator: sentiment. Putting it all together, let's see how these components come together in a prompt. In this example, instruction: classify the text into neutral, negative, or positive. Input data: text, I think the food was okay. Output indicator: sentiment. Notice that we didn't explicitly include context here. While it's not always necessary to include all four components, adding context can enhance the prompt by providing more information for the model to understand the task better. Why context matters: although our example works without explicit context, including it can improve the model's accuracy. For instance, as a sentiment analysis tool, classify the following customer feedback into neutral, negative, or positive. Flexibility in prompting: remember, not all prompts require all four elements, and the format can vary depending on the task. The main goal is to structure your prompts in a way that clearly conveys your intent, and directs the model to generate relevant and accurate responses. Tips for effective prompting: be clear and specific. Ambiguity can lead to unexpected outputs. Use natural language. The model is trained on human language. Speaking naturally helps. Provide examples if necessary, especially for complex tasks. Practice makes perfect. The best way to get better at prompting is through practice. Try crafting prompts for different tasks and see how the model responds. Adjust your prompts based on the outputs to refine your approach. Advanced prompting techniques. Now, we're going to delve into the fascinating world of advanced prompting techniques. As you may know, prompting techniques are an area of active research, with ongoing exploration of new methods to improve language model performance. While basic prompting approaches like zero-shot and few-shot prompting are well established, more complex techniques are being developed to further enhance model capabilities. The classification of these methods into broad categories is not exhaustive or final, as the field is constantly evolving. Many methods may overlap categories. Leveraging the advantages of multiple approaches. Overview of advanced prompting techniques. Our focus today will be on three main categories. 1. Step-by-step modular decomposition. 2. Comprehensive reasoning and verification. 3. Usage of external tools/knowledge or aggregation. Let's begin with the first category: step-by-step modular decomposition. What is step-by-step modular decomposition? These methods involve dividing complex problems into smaller, more manageable steps, supporting a structured problem-solving approach. By guiding the language model through a sequence of intermediate steps, it can address each part individually rather than attempting to solve the entire problem at once. Benefits: enhances the model's reasoning abilities, particularly beneficial for tasks requiring multi-step reasoning. Under this category, we have several techniques. 1. Chain of thought, CoT, prompting, zero-shot/few-shot CoT prompting. 2. Automatic chain of thought, Auto-CoT, tree of thoughts, TOT, prompting, graph of thought prompting. First, let's explore chain of thought, CoT, prompting. Understanding chain of thought prompting. Chain of thought prompting is a technique designed to enhance complex reasoning capabilities through intermediate reasoning steps. This method involves providing a sequence of reasoning steps that guide the language model through a problem, allowing it to focus on solving one step at a time. How it works: the prompt includes explicit instructions to think step by step. The model processes each step sequentially to arrive at the final answer. Zero-shot/few-shot CoT prompting. Now, let's delve into zero-shot and few-shot chain of thought prompting, which fall under CoT prompting. Zero-shot CoT prompting. Zero-shot prompting uses the phrase, "let's think step by step," to guide the model through a structured reasoning process without providing any examples. Few-shot CoT prompting. Few-shot prompting involves providing the model with a few examples of similar problems to improve its reasoning skills. Example. Let's move from manual chain of thought prompting to an automated approach. Next up is automatic chain of thought, Auto-CoT. Auto-CoT is a method developed to automate the creation of reasoning chains for demonstrations. Instead of manually creating examples, Auto-CoT uses language models, with a let's think step-by-step prompt to automatically generate reasoning chains, sequentially. Process 1. Question clustering. Group questions into clusters based on their similarities. 2. Demonstration sampling. Choose a representative question from each cluster and generate its reasoning chain using zero-shot CoT with straightforward heuristics. The aim is to automate the creation of diverse and effective examples, reducing manual effort. Under the automatic chain of thought, we have two more advanced techniques, tree of thoughts, TOT, prompting, graph of thought prompting. Let's now explore tree of thoughts, TOT, prompting. Tree of thoughts prompting builds on the chain of thought approach by allowing language models to explore coherent text units, thoughts, as intermediate steps in problem solving. Key characteristics, coherent units, thoughts. Models consider coherent text units as intermediate steps. Deliberate decision-making. Models make intentional decisions and assess different reasoning paths. Backtracking and looking ahead. Models can adjust their approach by revisiting or anticipating steps in the reasoning process. Why use TOT prompting? This structured framework provides greater flexibility in strategic decision-making, making it particularly useful for tasks that require detailed and adaptable reasoning. Moving on, let's discuss the graph of thought prompting. Understanding graph of thought prompting. This technique addresses the fact that human thinking often follows complex, nonlinear patterns rather than simple sequential chains. To better capture these nuances, graph of thought, GOT, reasoning models thoughts as graphs instead of linear chains. Key features. Nodes represent thought units. Each node is a distinct idea or partial solution. Edges illustrate connections. Edges show how thoughts are related or influence each other. Directed acyclic graphs. DAG's paths can branch and converge, providing a richer model of thought processes. How does GOT work? The GOT model operates in two stages. 1. Generating rationales. The model generates multiple rationales or reasoning steps. These are represented as nodes in a graph. 2. Producing the final answer. It employs a graph of thoughts encoder for representation learning, integrates these representations with the original input through a gated fusion mechanism. Prompt. Analyze the potential outcomes of implementing a universal basic income (UBI) policy. Provide a comprehensive reasoning using interconnected factors. Answer. Model's response. Node 1. UBI could reduce poverty levels. Node 2. Increased disposable income may boost consumer spending. Node 3. Higher consumer spending could stimulate economic growth. Node 4. Funding UBI might require higher taxes. Node 5. Higher taxes could impact business investments. Edges. Node 1 Node 2. Reduction in poverty leads to increased spending. Node 2 Node 3. More spending stimulates growth. Node 4 Node 5. Higher taxes affect investments. Nodes interact to show both positive and negative potential outcomes. Final analysis. Implementing UBI has the potential to reduce poverty and stimulate economic growth through increased consumer spending, but it may also require higher taxes that could impact business investments. To summarize, step-by-step modular decomposition helps enhance model reasoning by breaking down complex problems into manageable steps, guiding the model through structured reasoning processes, allowing exploration of multiple reasoning paths and complex thought patterns. Now, let's discuss the second category, comprehensive reasoning and verification. Comprehensive reasoning and verification involve a sophisticated approach where reasoning extends beyond simply producing a final answer. Instead, the model provides detailed intermediate steps and employs a self-verification mechanism integrated into its reasoning process. Key features. Detailed intermediate steps. The model articulates each step in its reasoning. Self-verification. It autonomously checks the consistency and correctness of its reasoning. Iterative refinement. If errors are detected, the model refines its responses to ensure logical coherence. This process enhances the reliability and robustness of the model's outputs, allowing it to adapt and improve through internal validation.